Class, in this clip we're going to go through the steps of drawing a contour map, of contouring the water table based on the measured elevations of the water table in wells, mapping the extent of groundwater contamination shown by observed concentrations of a pollutant in groundwater, and then making predictions about where that contaminant plume is going to move based on the direction the groundwater flow is carrying it, as shown by the water table contours. You're looking at a map showing water table elevations in blue, measured in feet, as shown by the height of water in wells drilled at each of these locations, and contaminations of tetrachlorine, tetrachlorine ethylene, which are measured in parts per billion and are shown in red on this map. Now this is a solvent, PCE. It's a solvent used in dry cleaning of fabrics and degreasing of metals. It's a biopersistent compound, and because it's a solvent, there's high potential for this compound to get into groundwater and contaminate that groundwater. EPA drinking water standards for PCE are concentrations no more than 5 ppb. You can see from the observed measurements that a number of these locations have concentrations in excess of EPA drinking water standards and have to be considered contaminated. We'd like to know where the contamination is, map out where that contamination is, make predictions about where that contamination is moving, where we're going to see concentrations in excess of the EPA standard based on the direction the groundwater flow is taking it. The first step is to contour the water table elevations. We see that there's a relatively narrow range of water table elevations here, a high of 336.8 feet, a low of 326.7 feet. I'm going to draw my water table contours at a contour interval of 2 feet, given I have such a narrow range of values. First contour would be the 336-foot contour. As you draw your contours, it's always a good idea to label those contours. At a 2-foot interval, the next one is going to be 334 feet. It will pass close to 333.7, pass also close to 334.7, but those points need to be on opposite sides of the 334-foot contour. 334.7 is higher, 333.7 is lower, so they're on opposite sides of that contour. 2-foot interval, our next contour is 332 feet. Again, all the points greater than 332 feet will be on one side of our line. All the points less than 332 feet will be on the other side of our line. A 2-foot interval, the next contour will be 330 feet. And our next contour will be 328 feet. Again, we're drawing our contours in such a way that we're separating points of lesser value on one side of the contour from points of greater value on the other side of the contour. Next step is to draw in groundwater flow lines, so in the direction that groundwater is traveling, based on the direction of the hydraulic gradient as revealed by mapping the water table. Lower elevations up here, higher elevations down here, water's flowing from south to north through the map area. As we draw our groundwater flow lines in, we're going to want to draw them in such a way that they cross each contour in a perpendicular direction. By crossing contours in a perpendicular direction, we're always moving down the hydraulic gradient. So we've drawn contour lines through the map area. We've added groundwater flow lines perpendicular to those contours, representing the direction that groundwater is flowing down our hydraulic gradient. Our last step is to contour where the contamination is, and then think about where it's going to move, based on the groundwater flow lines. Our concentrations range from 150 ppb to less than 1 ppb. I'm going to draw my first contour. And make it a 100 foot or 100 ppb contour. All the points greater than 100 ppb are on one side of the line. All the points less than 100 ppb are on the other. The next contour I'm going to draw is the 50 ppb contour. All the points greater than 50 ppb on one side. All the points less than 50 ppb on the other. I'm going to next draw a 25 ppb contour. Let's draw a 10 ppb contour. I'm going to swing out and get this point here. Need to get that point as well, and that point over there. That was 10 ppb. Let's draw a 1 ppb contour. Contamination source, probably somewhere in here. So the green contours represent where the contamination is in the aquifer. Where is the groundwater flow taking that, or how is the contaminant moving in the aquifer, and where is the groundwater flow taking it? Well, the contaminant is moving by two processes. One is dispersion. Dispersion is a molecular process. We're going from high to low concentration. In other words, the contaminant is dispersing down its concentration gradient. At the same time, the contaminant is mostly moving in one direction, as dictated by the groundwater flow direction. Movement of groundwater in the aquifer is moving the contaminant to the north. At the same time, the contaminant is dispersing in all directions down its concentration gradient, resulting in an oblong or teardrop-shaped contamination plume. Dispersion in all directions, but much greater movement in one direction based on the direction the groundwater flow is moving.